Now, just to make this example a little easier, I just want to change my value of gravity. The acceleration due to gravity, we know the exact value for objects on the surface of the Earth. 9.8 meters per second squared, and it's down. So your velocity is actually changing by 9.8 meters per second every second in the negative direction. But just for this question, just to illustrate the point, and so we can do it in our heads, let's just round that off to 10. Let's say our acceleration is negative 10 meters per second squared. But again, let's think of that as negative 10 meters per second every second. That's how quickly my velocity is changing. So let's make up some numbers. Let's imagine this person throws the ball into the air, and the second the ball leaves its hand, it's going to be under the influence of gravity only. And let's imagine his initial speed when it leaves his hand is 30 meters per second. Now, if my acceleration is negative 10 meters per second every second, that means my velocity 1 second later, when I take 30 and I add negative 10 meters per second, will be 20 meters per second. So on its way up, it's slowing down. Now, if it's at 20, and I add another negative 10 meters per second, remember every second its velocity is changing by negative 10 meters per second. That's what acceleration means. It won't go as far now, but it'll only be going 10 meters per second. And then 1 second later, it'll be at its peak, and right at the peak, it's going to be going 0 meters per second. And then it'll start to fall back down towards Earth. So from the peak, 1 second later, now it's going to be going 10 meters per second, but down. So I'm going to say negative 10. Notice 0 plus negative 10. I add negative 10 every second, gives me negative 10. 2 seconds later, he's going negative 20. I've added another negative 10. 3 seconds later, he's going negative 30 meters per second. So the left-hand side shows the ball on the way up. The right-hand side shows the ball on the way down. Now it says, what is the acceleration when the velocity is 0? And we can see that on the way up, the ball is slowing down, slowing down, slowing down, and then right at the very peak, at the top of its path, its velocity is 0. So the velocity is 0 at the peak, at maximum height. Now, at this point, what's its acceleration? Now, the most common mistake is that people will say that the acceleration is 0 because the object's not moving at the top. But remember, that's not what acceleration means. Acceleration is describing how quickly your velocity is changing. Is my velocity going to be something else 1 second later? Yes. 1 second later, after it's at the peak, it's going to be going negative 10 meters per second. So it still has an acceleration of negative 10 meters per second squared at the peak. You can't just turn off gravity. Now remember, we rounded off gravity to be negative 10. So the actual acceleration at the peak will still be negative 9.8 meters per second squared. One thing to keep in mind is acceleration is always a result of a force. And the force in this case is the force of gravity. And it doesn't suddenly turn off just because the rock's at the peak of the path. That's why your acceleration's always constant and always driving that object back towards the Earth.